All right, and for the second part of this, we're going to go ahead and get into our bimolecular processes, which are non-carbocation forming systems. So right here, you're going to start with your nucleophile, and your nucleophile in SN2 and E2 really want to go to this spot. It wants that spot right there. It's perfect for it. It's very hard, as we talk about in the class, and it wants to hit this spot. And on top of that, this spot right here, this leaving group that's connected to that spot, wants to leave. It wants to go. So what you'll actually end up forming almost, if you will, is you're gonna end up forming something along the lines of this. If you just give me a moment here. You have your hydrogen. And then you have your leaving group, which is partially bonded. And you have your nucleophile, which is partially bonded to it. And then you have your Z and your Y. And you can see here, like this carbon right here is bonded to both this nucleophile, semi-bonded to this nucleophile and this leaving group, because these processes are happening at the exact same time, which is why there's no carbocation forming. This is leaving and this is coming in immediately and taking its place, which is why there's no carbocation. There's no time. And that can happen for a number of reasons. So some of the reasons why something like that could happen is that this nucleophile is really hard and it really wants that spot. And another reason could be, so you've got one, that nucleophile. You've got two. This leaving group may be very happy with leaving. It might really want to go. It's just ready to leave. It can be, and then the third process, or the third reason why this could happen is that this carbocation would be very unstable, or that this thing wouldn't want to stick around. So the carbocation that would exist there basically would not be stable at all. And some of the things that could cause that is if it's a primary carbocation. So if it's a primary carbocation, that means it's only attached to one carbon. So a primary carbocation would look like this. That's a primary carbocation because you can see here that it's only connected to one carbon, just one. And then a secondary, which is not going to, secondary is kind of in the middle. It's not going to lean towards a carbocation being formed, and it's not going to lean towards no carbocation being formed. It's just kind of in the middle. That's a secondary. And then this would be a tertiary carbocation. Now, a tertiary carbocation, if you do have a tertiary carbocation, that's possible, or if that's what would form, then that's very possible that you're going to get something up here in the monomolecular processes, because if that carbocation is tertiary, it's pretty stable. They're normally content with being this sort of carbocation as opposed to a primary. So if they're going to become a tertiary carbocation, that is something that you can go ahead and mark under the idea of it being possibly an SN1 or an E1 reaction, because it forms that carbocation and it says, this isn't that bad. Like, we don't need to immediately get a nucleophile in here. We don't need to immediately have a charge there. That's okay. And they're fine with that. All right, so going from there, we are going to move into our E2 process. So elimination 2, you're going to have your nucleophile. Again, just like the last elimination process, it's going to attack this hydrogen. However, something that'll make this one very quick is if this leaving group is, like the last one, very happy with leaving. That leaving group wants to go. It's totally content on its own. It's something like an iodide. An iodide is a fantastic leaving group because it's big. So an iodide is huge. It's like this humongous thing. And that negative charge is kind of spread out amongst the whole thing. Whereas something like a fluorine, this little thing, that negative charge is going to be just in that tiny little spot. So it's not nearly as balanced out as this. So that leaving group will leave very quickly, and at the same time, your nucleophile is going to come in here and smash into that hydrogen and take it and steal it. And then you'll be left with this nucleophile, or this one, with that hydrogen, and the leaving group is just hanging around, and you've had your elimination reaction already with no need for a carbocation. And another reason why something like this can happen is because of that idea of the primary, secondary, and tertiary carbocation. If you have a primary carbocation, so if that's what this is forming, when this thing leaves, when that leaving group leaves, and this forms a carbocation, let's say it's primary, it's something like that, and these are like 2 hydrogen groups, that will be very, very unstable, which means that it's not going to want to form a carbocation. It's just not going to want to make it. It's not stable. It's going to revert back. So it won't do it. But in the case of, say, it's a tertiary carbon, so say these are both 2 carbon molecules now, then it'll say, you know what, this is okay. We don't need to, like, we don't really need this to happen so quickly. That's all right. So it might be an E1, because an E1 is going to be content with that carbocation forming, and this one will not. But back to the E2, that nucleophile is going to come in and take that hydrogen at the same time that that leaving group happens, leaving no time for a carbocation to form. And you'll be left with your nucleophile charged or linked with that hydrogen. Your leaving group is in solution, and you've had your elimination process.